Okay, so this is going to be part 1 of lesson 1's notes because they take a little bit longer than for the 15 minutes. Okay, so we're going to talk about the sine and cosine functions. So we're going to start off by picking some x values. If we remember from our trig 1 unit, we have our unit circle that happens with angles 0, pi over 2, pi, 3 pi over 2, and 2 pi to go all the way around. And if we remember, sine theta was equal to the y values that were happening during this. So the y values here would be 0, 1, 0, and -1, and then 0 again. So I'm going to pick these quadrantal angles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to fill in what the values of 0 or y are at each one of these. They are 0, +1, 0, -1, and 0 again. So what I'm going to do is I'm going to stretch this out onto a xy coordinate plane where x is now the angle and y is our up and down value. So we've got pi over 2, pi, 3 pi over 2, and 2 pi. And our values there, we've got 0, 0. Pi over 2 is at +1. And then we've got pi. And then 3 pi over 2 is down at -1. And then back up at 0. And we're going to we're going to connect these with a nice smooth curve or a wave. So it goes up like that and then down. And there we go. So this is our sine wave. As we continue to go around the circle, it will continue on. So just to give you a sense here, highlight. This part of the wave here, and you cannot see, this part here, it's not highlighting. Between 0 and pi over 2, that corresponds with quadrant 1. That is between 0 and pi over 2. And sine is positive. So you can see we're heading from 0 up to 1 in both of these. And then in quadrant 2, sine is still positive, but we're heading from 1 down to 0. As you can see, this is what we're doing here. And then in quadrant 3, sine is negative. We're heading down to -1. And then up, it's still negative, but we're heading back up to 0. Okay? So this function then can continue on because I could go around the circle backwards. So negative pi over 2 would be down here at -1, and then up to negative pi would be at 0. And we can go and continue on through the circle and continue. So this is why this is called a periodic continuous function. So it'll continue on forever, and we're going to have different periods or wavelengths. So the domain of this function is x is all real numbers. The range is -1 is less than y is less than 1 because we're low point at -1, high point at 1 on our y values. So max is 1, min is -1. Period is 2 pi. So the period is the length of one wave. So from here it is, you can see here we go up and then down and then back to the x-axis. So this would be the period. And it is 2 pi. We can also measure it from peak to peak, which you'll see in the next one, and trough to trough, which is a common one. So this is always to measure the period. Amplitude is from the middle of the wave to the top of the wave. So that is here. This is amplitude. It's always positive. So in this case, it is 1. Our y-intercept is 0, 0. And our x-intercept is, you can see it happens a lot. It happens at 0 and then pi and 2 pi. So we start at 0. We go plus or minus pi n, where n is an integer. So that is our sine wave. our cosine wave, we're going to do the same thing. We pick the same x values. 3 pi over 2 and 2 pi. But this time, if you recall, our cos theta, was equal to x. So our quadrantal angles, here x is equal to 1, here x is equal to 0, x was equal to -1 here, and 0. So this more looks like 1, 0, -1, 0, and 1. So if I draw that out, pi over 2, pi, 3 pi over 2, and 2 pi, 1 and -1. Now I've got my first point is up there, and then I cross the x-axis, and then I'm down at -1, and then back at the x-axis, and then back at 1. So you can see my cosine wave is just my sine wave shifted over by pi over 2. My domain is x is all real numbers. My range is still -1 to 1. Max is still 1. Min is still -1. Period, you can see here now that this is what I meant by peak to peak. It is still 2 pi. Amplitude is still middle of the wave up. It is 1. Y-intercept this time is 0, 1. And the x-intercept, now we start at pi over 2 plus or minus n pi, where n is an integer. All right, so y equals sine x and y equals cos x are both continuous periodic functions because the graphs have a repeating pattern for a certain length. Given the graph below, determine 4 other points. I'm just going to do 3 other points with the same y value as 2 pi over 3 and root 3 over 2. So this point right here, I'm just going to switch to blue, is about here. Two pi over 3, root 3 over 2. And so you can see the root 3 over 2 happens again here, and then here, and then here. So what we are going to do is we're going to pause. All right, so this 2 pi over 3 we know is in quadrant 2 and has a reference angle of pi over 3. And this is our 2 pi over 3. So where else is sine positive? Well, it's positive in quadrant 1. So this point here then must be pi over 3 in quadrant 1. And then this point over here is exactly a wavelength away from 2 pi over 3 in the negative direction. So it is actually this measurement here because it needs to be in quadrant 2 to be positive again. So this one is -4 pi over 3. And then this spot here would be all the way around again to here. And this would be -5 pi over 3. So this is part 1 of our lesson 1 notes for sine and cosine wave.